Hello guys, welcome to KTU lectures. In this part we will be starting our single cycle processor discussion, and we will learn single cycle processor using this question here. We have this complete question here. That means first we will cover here this. There are different instructions. You can see one load instruction is the, one store instruction is the, an OR instruction is the, a branch instruction is the. So we will see how each of these instructions are basically covered, or how you are basically able to solve these instructions using single cycle processor. Okay, that is in single cycle processor, how this instruction, the CPU, how single cycle processor is basically designed to do this instructions are what we are going to basically discuss. So let's get started. So first of all, we will be doing in this video how this load instruction is basically, that is first we are discussing this type I. In type I in type I, this is the instruction that we have: load S6 comma minus 4 x9. Okay, we are going to see how this instruction is basically arranged in the single cycle processor. So this is the basic structure of single cycle processor, which we have already learned in the previous way. The basic things which is in there in a single cycle processor or single cycle a processor is that we have this PC. We have learned what is PC nest and what are PC already in the previous videos, so do check that out. And then we have the instruction memory and data memory. In instruction memory we have set the address, input address is coming through this A, and the instruction is, which is in the machine language form, is through this RD it will go. Here the address of the instruction is given by the PC, and then the instruction is given out in the instruction memory, which there is register file. Register file have these A1, A2, RD1, RD2 are the read ports, A3, W3 are the write ports. This is what the registers are doing. Then we have the data memory. Data memory, you can see here, read port are A and RD. To read, and an address will be passing through this A, and the data which is present in that address is going through this RD as the output. Or WD is for writing. We will write the 32-bit thing value here in this address. This whatever we write in WD is basically returned into the memory. This is what is the basic structure. I just give you a brush out, but the detailed explanation is there already in the channel itself, so please go and check that out. Now guys, we have this load instruction to us, which is, this load instruction is present in this address of the memory. So in our memory, in the address 0x1000, this instruction is present. So we understood load. We already have learned that load is what? Load is present is a which type? I type. And this is the format in which you're going to, first you have to convert this instruction into what? The binary number, and that binary number you have to later convert into its machine language. So first of all, we will see how this instruction, that this load instruction of type I is converted to its. We have already learned how we will do that, but let's see. So in the type I, we have the immediate bit first, that is the first immediate 7 bit is there. Then type I means one, you have 2 registers also there in the type I. So it is add I like that. So it means you have destination register RD and also one register RS1 also. So then you have this RS1 5 bits. Then you have function 3 value, that is 3 bit. In this is type I, how you are going to write type I. Then you have RD for the destination register, which is 5 bit. Right, then you have the opcode, which is 7 bit. What is the opcode for load? The instruction here is load. So first the opcode for load is 7 bit it is. So it is what? First last 2 bit were 1 1. This is something we have already learned, guys. So do check that out in the previous videos. You have to really learn the previous videos very well. So the opcode for load is this, which we have already learned, and this is the format. First 12 bits are the immediate bit, then rs1 is the source register, function 3 value to show which operation is happening here, and for lw load, what would be the function 3 value? We have said we have lb, lh and lw here. That is, it is 0 0 0 for lb, 0 0 1 for lh and 0 1 0 for lw. So the function 3 value of lw is 0 1 0 for this instruction. So here you will write 0 1 0 for that instruction. Here the opcode we have already told, it is this. So we have the opcode here. Now we have to write the immediate value. Now what is the immediate value in this instruction? See, function 3 values, this much I told you already to learn. LW function 3 values 0 1 0. These are the things which is there in the previous classes, so do check that out guys, otherwise you won't understand how to write this. Okay, so function 3 value, this and this part is done. Now immediate value here is -4 and it is 11 bit. So first of all guys, I have to write 4 value in 12 bits. So 4 is what? 4 is 0 0, 1 is 4, fine, 0 1 2, right? That is my then rest of the thing you can write it as 0 bits for the 12, rest would be 0, fine. Now you have to take the ones complement of this, that means 1 1 0, then 1 1 1 1 1 1 1 would be the ones complement, fine. Now 2's complement, it should be 12 bit, 1 2 3 4 5 6 7 8 9 10 11 12, ones complement of 4. Now 2's complement you have to plus 1 1. When you do plus 1 you get 0, what you will get? 0, again 0, then 1, then 1 1 1 1 1 itself. This is what you get when you do plus 1, right? So that is this value in the immediate. So 12 bit, first you take the 4's 12 bit value, then you take the 1's complement, then you add 1 to it, right? So I know this is a very messy slide right now, so I'm going to erase these things what I have wrote here. So right now you understood how we got this I hope you understand how we go this -4 value here, fine. Now we have done what would be this function 3 value and opcode is done. Now rs1 is the source register. So here the destination register are x6, this x9 is the rs1 value, because this is the value in S6. We are going to load the value which is present in this memory location. So this is the destination register, this is the source rs1. 9 you have to write it in 5 bit. So first of all, what is the value of 9 guys? The binary form of 9 is 1001, right? This is 8 plus 1. Then 5 bit means 1 more 0, so that is what here the rs1 value. Then rs2 values 6, that is given here, 6 values given here already, that is 4 plus 2 is 6, that is here already in 5 bit you have written. So now you got what? Now you got all of this value. Now the thing is to write in the machine language, so you're going to take pair of 4. From the backwards you take this one pair, this another pair, okay? I will write it in the next slide if you want. Guys, if you see, this is one pair, 4 pairs you are going to take now. So I am taking 4 pairs right now. You can see how I am taking this 4 pairs. So we have these 4 pairs with us. Now 0 0 1 1 is what? What is the binary number? 0 0 1, that is 3. So we write here 3. You can see I write here 3. Then 0 0 0 0 is 0 itself. Again I write here now 0. Now 1 1 0 0 is again 3. Fine. Now 0 1 0 1, what is that value? 2 plus 8, that is 10, and we know 10 in hexadecimal is A. Okay, then 0 0 1 0 is basically 4, so we write here 4. Okay, then 0 0 1 1 C, then full 1 1 1 1 F 15, that is given here. This is how the machine language is written. So now you have understood how the instruction that you got with the knowledge of the previous lectures that we have learned right now, how can you convert it into this machine language format. Fine, this much is done. Now how we are going to write the single cycle processor is my first step. So first step is to load the instruction in the instruction memory. So that means the PC, I told you what the PC do. PC would give the address of the instruction, that is 0x100 to the instruction memory A. So the A, what does A do? A take this input address, that is in which the instruction is present, right, in the memory. 0x1000 is a location in which this instruction is present. So what does instruction memory do? It take that input of the address. Fine, it take that input of the address, and that is the 32-bit. Okay, it takes that and gives out the instruction, that is this machine language instruction you see. Yeah, the instruction which is present in that address, that is this machine language instruction that we got, is given out to the RD. This is the first step of designing. Understood? Now in that instruction, what the instruction is telling us to is the load instruction. Load means what? In the register value x9, right, x9 minus 4, I have to load that value into S6. That is, I am loading the value of this x9 minus 4's value into S6. So first of all, what I have to do, I have to read the value which is present in the x9 register. That is the main important thing that I have to do. This x9 register is this, that is this 9 is basically passing through here. Okay, now 9 is this bit, that is RS1 bit. 19 is to 50, that is why it is given 19 is to 15, because I am passing this bit, RS1 bit, because we know this is 32, this is 31, 30, 29, 28, 28 is this, 27, 26, 25, 24, 23, 22, 21. It's actually start from 31, right? Okay, so it will be 20. Now this is 19 bit. 19 bit to 19. This is 19, this is 18, this is 17, 16, 15. So till this much bit is passed through A1. That is what? In the instruction 19 is to 15, that bit is this. That is given to the A1. That is register 9. So if you see in our register file, I will show you, this is some previous section information, but still to complete or give a good setup, I wanted to explain that also. See here guys, instruction memory 32-bit address. Now register file we have to see. Now A1, A2 are the 5-bit register values that we are taking. It contains address of register to read, and RD1, RD2 gives the data output from the addressed registers. That means first I am giving this address register RS1 through this A. My A1, I want to read the value in A1, right? First I have to read the value in the A1. So now what I do is that I read the value in the A1. So you have to understand here guys, I'm reading the value in the A1. And also I am taking that instruction. So you have to understand here. Okay, I will just show you what we are going to do right now. I am reading the value in the A1 and that data would come. Okay, what is the value which is coming from that X9 location, and that data, now this is ALU guys, this is ALU. It has to add what? Now I have this 5-bit, sorry, this 32-bit immediate, that is 31:20 is what? This immediate bits. Now this immediate bits are passed through the immediate extent. Now that means this number is this in machine language. So I want to extend it because the ALU, you can pass only 32-bit values to ALU. So what happened is that this is just the data which is present in that location is this. Okay, and then I am going to add both of this -4 plus the value in X9 we have to take, right? Value in X9 we have to take. These two values are added, that is why ALU control has 0 0 0. This is ALU. What does ALU do? It can do arithmetic operation and all, right? So immediate extent would extend the bits in the it would extend the bits which is present in our immediate values, and that is added with the value in this X9. Okay, so you get a location. So what happened is that in X9 register files, value is added with the immediate address to get a new address, and I have to find the data which is present in that address. If I say, now I got this ALU result right now, and I have to do what? This is my data memory. Let us say load means what? I am loading from the memory actually the data value, right? So that means in this address there would be one data which I have to read from the memory, and that data which I have read is loaded or it's returned into our register. The data value that is present in the address is returned into that value. Let's say in that location 10 is there, that we have to write it into the register. That is what load means. So I will write the reg write to be 1. That means I need to write to the register, and the value that I have to write to the register is passed through WD3, and the address location in which I have to write it is passed through A3, which is 6. In here I have to pass this return value. So reg write. So this much is only what we have to do. Okay, now I will explain it again because I know there would be a lot of students who didn't get it. So guys, what does load means? If you doesn't understood, I will explain it again. That is, what is load means? Load means there would be one, I have to take the, that means in this address location in the memory, this address locations data I have to write it into this register. So this location would be present in the where? In our memory. Okay, in our memory. So we have to find the data which is present in this location in the memory and load it into S6. So this much you have understood. The instruction has come. Now that instructions, first of all I need to take the address of X9. If I want to take the address of S9, what I have to do? I have to pass the first bit. That is, first I have to pass this 9 to the register 5. The 9 is present in this bit. Okay, so I am passing this bit, that is 19:15 bits to A1. Fine. And this A, then it will read the value. RD1 would read the location of that. Let it was read as some 200. This would be the location in which X9 is present. Okay, fine. Now we have our ALU. Now ALU control is there here. So in ALU, what this X9 location -4 I have to do to get the location, correct location, the data memory. That is what load means. So I have to do -4. So in this instructions, what happened is that this ALU, we need to write 32-bit here. but here it is immediate extender is needed because this is 12 bit. Okay, I need to convert it to 32 bit, so I'm using immediate extend. That immediate extend -4 value, here -4 is passed through, here machine language -4 would be there, and you're adding that both to the ALU using the ALU control. That is 000 means what? Okay, ALU 00 means I am adding. So in ALU, addition is 000, and that added values would be some 0x200 something. Maybe if this is 204, this is, let's say we have given the address in which 9 is 0x some 0x2004, and when I'm doing -4 I get 0x200. That address location is passed to the data memory. Okay, fine. Now what I have to do, I have to read the value in that address location from the data memory. Let us say it is some 10. Then I have to load it into this register S6. So S6 is present over this bit, so we have to write this bit from the instruction itself. I'm taking that particular bit in which RD bit, and I am writing this value of 10. WD3 gives the WD3 means what? The data that I have to write into this address A3. So write enable would become 1. So the 10 value is returned to the location of S6. Understood? This is how it works. So if I'm seeing here, immediate extender, what does it do? Immediate extender, if I'm having 0x FFC, because this is what C, this is F, this is F, I have to extend this bit. So just write more F's here. I have it extended. This is now 32 bit. I have extended this bit, and this 9's location we got 0x2004, that minus this 4 we have done. So we got, that is, first it was the address of 9 is 0x2004. That is a value in 9. Okay, and the value and the extender is written here in the machine, both the machine language forms. Okay, and ALU control value is 000 means you're going to add this both. That means 0x2004 -4 will be done, because it is plus -4, because this value is -4. Fine. So you get 0x200. Now in the data memory, this locations data we have to read from the data memory. So we read it out as some 10. That I am going to write it into this register files S6. So S6 is the bit, that is 11:7 is that bit that is passed through this A3, and WD3 would pass the data which you have to write to this, and we have to write the WE3. Write enable should be 1 here now. Fine. So in that way we have load this locations data to this S6. This much we have understood. Now what happened? The current instruction plus 4 I have to do. Again ALUs the plus 4. If I do, I get the next instruction to solve. Now the next instruction is present in 0x1004. Now I have to do the next instruction. Understood? So now I have to do the next instruction. Now what are the things that is written here? The load instruction execution stages through the data path. First it's read the base register. See here, the base address register is this RS1, that is 19:50. So these 5 bits connect directly to this A1 port in the here, right, A1 port in the register file. These 5 bits connect directly to the A1 port of the register file, and the register file reads the register's value and give the output. So the register X9 contains this value, that is one address. So that value you have to now sign extend immediate is also there. That is the stored in upper 12 bits of this instruction. Since it is signed value, it must be sign extended to 32 bit before use. Sign extend the immediate offset means, since it is a signed value -4, what we have to do is that we have extended it to the 32 bit and stored it in this. What happened is that now immediate extend becomes original 12 bits. Now if the sign bit is 1, the upper 20 bits are filled with ones, and if 0, it is filled with 0. So what does it means? That here we know the sign bit is 1, right? So that means in our immediate, the sign bit is 1 means what? We have to fill it with 1. That is why we have written this FFF, because filling it with 1 makes it FFF, right? Because 1 1 1 is F. So I filled it with 1. If the sign bit is 0, that means I will fill it with 0, not with 1. Understood? This is how we are going to do the extender. Okay, we have to sign extend to 32 bit before it use, because it is what is sign bit. So this is an important type of question that can ask. Before it was like this, now I have sign bited and added more ones to it. Okay, so this all 20 bits becomes ones. That is what it basically happened. This is how sign bit is actually done. So this is how the load instruction. So now I hope load instruction in the single cycle processor is very clear. This is the final diagram of the single cycle data path design. So in the next video we will do the next instruction, because if you see in this question, the next instruction, now this instruction would come, that is store instruction. So we will see how this instruction is getting executed in our single cycle processor. So make sure you learn all the previous videos very clearly, then only we will be able to understand this. So till then, take care and bye. Thank you.